Hi all. In section 1.9, we're looking at the distance and midpoint formulas, and then looking at circles and their equations. Good section. So looking at the objectives of what I'll need you to do in this section, first and foremost is I'll ask you to find the distance between 2 points using the distance formula. If you prefer, you can always use the Pythagorean theorem to find that distance as well. Find the midpoint of a line segment. Write the standard form of a circle's equation, and then if I give you the center and radius of a circle give the center and radius of a circle whose equation is in standard form. So if I give you an equation in standard form of a circle, you instantly need to be able to look at it and tell me where the center and radius is. And then lastly, we're going to convert the general form of a circle's equation to standard form. Okay. Now, first up, the distance formula. Now, this distance formula just comes as a result of the Pythagorean theorem, where we say the hypotenuse is nothing more than the square of the horizontal side plus the square of the vertical side within a right triangle. The a squared plus b squared is equal to c squared. Well, this is just solving for c. It says that c is equal to the square root of a squared plus b squared, where a is just the horizontal change and b is the vertical change. That horizontal change, instead of calling it a, we call it x2 minus x1, and the vertical change, instead of calling it b, we call it y2 minus y1. But now, if we have two ordered pairs in our system, x1, y1, and x2, y2, it's probably easier for a lot of people just to say, well, then the distance between those two ordered pairs is the square root of the change in the x values squared plus the change in the y values quantity squared. Now, to see an example of that, I'm asking you to find the distance between the ordered pair -1, -3 and the ordered pair 2, 3. All right, so the distance formula says it's the square root of the change in the x values squared. Well, that's going to be x2 minus x1. That's 2 minus a -1. You'll see I put that in the next step, and we need to take that difference and square it. Well, then it's plus y2 minus y1. Well, that's going to be y2 minus y1, 3 minus a -3. You see I put that into the equation, and of course we square that distance. So it's the change in x squared plus the change in y squared. 2 minus a -1 gave me a 3 because it was 2 plus 1. Similarly, 3 minus a -3 is just 3 plus 3. I get the change in the y value at 6 units. Now, I wanted to show this step right here because I see so many students make a horrible, careless mistake here. They'll say that the square root of 3 squared plus 6 squared, and they'll say, ooh, the square root and the squares cancel, so can't I just call this 3 plus 6, which is 9? Horrible, 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 horrible. What you need to remember is inside of that square root, there's an understood group that says you need to simplify everything inside of that before evaluating the root. So that means I have to go ahead and square out the 3 to get a 9. I have to square out the 6 to get a 36. And now I need to simplify 9 plus 36 before I can even consider taking the root. Well, 9 plus 36 is 45. My answer to this distance formula is, well, the distance between those 2 points, it's the square root of 45 units. That's how far away from one another they are. Now I need to simplify that. I wouldn't want that as your final answer. So you say, well, 45 has a perfect square factor of 9. So I know I could call that the square root of 9 times 5. I know the square root of 9 will simplify as a 3. So my best root answer would be 3 on the root of 5. Now, your book will have you, in the homework problems, give the simplified root expression and the decimal approximation, whenever it's not a whole number, to 2 decimal places. And in this case, 3 on the root of 5, or the square root of 45, would simplify to be 6.71. So they'll always want 2 decimal place accuracy in this section. Now, the next topic in this section, it has us find the midpoint between 2 points on a line segment. And that's easy to think about if you just say, well, if I need the midpoint, the point exactly in between two coordinates x1, y1, and x2, y2, then simply just take the average of the x values and the average of the y values. Well, the average of those x values, how do you find the average? You sum up the number of x values you have, you divide by that number. So it's just the average x value is x1 plus x2 over 2. The average y value is y1 plus y2 over 2, and this will give the midpoint. To show that, I'm asking you to find the midpoint of the line segment that's connecting the ordered pairs 1, 2, and 7, negative 3. So you'd say, well, all right, the average x value, it's going to be 1 plus 7 divided by 2. The average y value, 2 plus a negative 3 divided by 2. So this is the work I'm doing. Of course, in this one, I'll get 1 plus 7 is 8. I'll have 8 over 2. 2 plus negative 3 gives me a negative 1 for that numerator, still over the 2. My average x value, or the midpoint in terms of x, it's going to be 4. And then the average y value, negative 1/2. So the ordered pair 4, negative 1/2 would be exact midpoint of that line segment. Now, we move on to the more interesting topic in this section of circles. So first of all, I need you to remember that a circle is just all the sets of points in a plane that are equidistant from some fixed point. The fixed point in the center itself is not part of the circle, but it has to be defined, whatever the center is, so that the circle is defined as all points in the plane equidistant from that center point, even though that center is not part of the circle. Only the points on the surface of the circle are parts of the circle. The fixed distance from the circle center point to any point on the circle is called the radius of that circle. Now, a formula for any circle can be as follows. It says the standard form of any equation of a circle with a center. Please notice the center of this circle is going to be located at some ordered pair hk. And the radius of the circle, the distance the points on the circle are from the center of that circle, is a distance of r. Well, my formula for that is going to be x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, this goes back to horizontal shifts where you say, okay, well, if it's shifted h units to the right, it's always x minus h quantity squared. If it's shifted h units to the left, it'd be x plus h units. Or x plus h quantity squared. So please remember, you're always going to do the opposite of the sign whenever it's in with the variable inside of the function. So I can say, well, okay, in this case, if the x component is at h units, then I'll subtract h in with the x value squared. And if it's k units up, then it's going to be y minus k quantity squared. And that's set equal to your radius squared. Now, remembering this formula, we apply it to a specific problem. I'm asking you to find the equation in standard form of a circle with a center at 0, negative 6, and a radius of 10. Well, you just look at your basic standard form, and this is going to be super easy. You just say, well, I know my center is hk, so I'll substitute in a 0 for h and a negative 6 for k. Well, if k is going to be negative 6, then y minus k, it's going to end up being positive 6 here. And then my radius of 10 becomes r squared, 10 squared. I get a 100 on the right-hand side. The equation of this circle in standard form is just x squared plus y plus 6 quantity squared is equal to 100. Now, of course, you need to be able to work these in both directions. If I give you this equation, you need to be able to look at it and say, okay, easy. The radius of this circle is the square root of 100. It's 10, and it has a center at the x value of 0 and at the y value of negative 6, which is what I'm doing in this next problem. I give you the equation of a circle in standard form, and I ask you to analyze that and tell me what the center and radius is. So you say, okay, the center. What's the x component of the center? It's always the opposite of this. So you'd say, well, the x component is negative 3. What's the y component of the center? It's the opposite of this, so it's going to be at +1. This is a circle at the ordered pair -3, +1, and it has a radius of the square root of the other side. Square root of 4 is 2. So this has a center of -3, 1 and a radius of 2. Now, whenever we look at, we've been looking at the standard form of a circle. We talk about the general form. The general form of any equation is going to put all constants and variables on one side and has a 0 on the other. So the general form of an equation is going to be x squared plus y squared plus some number d times x plus some number e times y plus some number f is equal to 0. Now, whenever we try to think about how could we work with an equation in that general form to be able to find out where the center and radius of the circle is. And I love, love, love problems like this because they're going to bring back the importance of completing the square. So here's what you do. If I'm trying to put this equation in standard form, I first need to collect all of my x terms. I did that, x squared plus 4x. Then collect your y terms. So I'll say plus, I have y squared minus 4y. Now, I'm confident that -1 isn't going to be helpful on the left-hand side, so I went ahead and moved it to the right. So please notice, I've collected the x terms, I've collected the y terms, and I moved the constant over to the right-hand side. Now, I want to create a perfect square trinomial from these terms of x. Automatically, you should remember what and how I'm adding this here. Every single solitary time, the constant c needs to be half of b quantity squared. So where did this 4 come from? It comes from 4/2 quantity squared. 4/2 is 2. 2 squared is 4. I need to add a 4 to make this a perfect square trinomial. Now, unfortunately, it's the exact same number in the second one. We have a -4y, but do you say, well, does it matter? No. Half of -4 is -2. -2 squared is still a +4. Perfect square trinomials always have a positive constant term in there. But now, hopefully you're thinking, well, okay, from this step to this step, he added a 4 to this group and he added a 4 to this group on the left-hand side. You can't add something to the left-hand side unless you make up for it by adding it to the right-hand side. Well, I did. I added 4 twice to the left. I added 4 twice to the right. Now I can see on the right-hand side that 1 plus 4 plus 4, I'm just going to get a 9. Now, it's important to be able to understand why I did these perfect square trinomials. It was with the entire point of putting this back into the standard form of a circle. X squared plus 4x plus 4 can be written as the binomial x plus 2 quantity squared. We all know that if we take x plus 2 times x plus 2, it would give you back x squared plus 4x plus 4. Similarly, the trinomial y squared minus 4y plus 4 is better written as y minus 2 quantity squared. Y minus 2 times y minus 2 would give you back y squared minus 4y plus 4. So this is the more efficient way to write it. Not only is it more efficient, but it puts it into the standard form of a circle where I can say, okay, now in this format, I can see that the center is at -2, +2. Remember, it's always the opposite of these signs. So the x component of the center is at -2. The y component of the center is at +2. And with a radius of the square root of 9, which is 3. Excellent problem there. Now, please do try the homework in this section. Let me know if you have any problems. Keep in mind, I've worked all of the problems assigned out of the book, which should mirror your My Math Lab assignment very closely.